This video will be on two word problems involving functions. The first one is pictures cost 25 cents each. So if I wanted to write that as an equation, and I'm going to do this for you, I could write y equals 25.25 times x, which means 25 cents times how many pictures I take equals total cost. So y is my cost and x is the number of pictures. All right, the first thing for you to do for A, write this in function notation. Figure out which is dependent, which is independent, what depends on what is a function of what, and write that in function notation. So you could have written y is a function of x. The cost depends on the number of pictures taken. The cost is a function of how many pictures were taken. So there's function notation. Your independent variable, x, is the number of pictures taken. Your dependent variable, y, is the cost. How much it costs depends on how many pictures you take. If we drew a quadrant 1 graph, your x-axis would be number of pictures taken and your y-axis would be total cost. All right, if y of x equals 0.25x, find y of 5, which means how much does it cost to take 5 pictures? So you would plug 5 into place of x, work it out, and your answer is $1.25. So y is a function of x. We plugged in for x, 5 pictures taken, and we got a total cost of $1.25. Let's do one more with that. Find y of 12, which means how much does it cost to take 12 pictures? So if you plug 12 in and work it out, you get 3. So sending 12 pics costs $3. For C, what is your domain? What is your domain? Domain is the independent variable, which in this case is pictures sent. So here our domain was 5 and here our domain was 12. So if you looked at this one and said 5, or you looked at this one and said 12, you're right. Or if you just said domain or pictures, the amount of pictures sent. How many pictures I send is my domain. It's my input. It's my independent variable. What is your range? Range is the dependent variable or your output. In this case, your output is how much it costs. For this particular one, your range was $1.25, and for this particular one, your range was $3. But in general, your range, your output, your dependent variable is how much it cost. Your domain, your input, your independent variable is how many pictures you sent. All right, let's do another one. I'm going to ask you several questions about it, but the real life problem is Bill makes $10 an hour cutting grass. Write this in function notation. Depending on what variable you used, your function notation might have been capital M, parentheses, lowercase t. Money made, money earned is a function of time worked. That's how I would have done it. But how much time you work is your independent variable. And how much money you make is your dependent variable. How much money you make depends on how much time is worked. All right, B, write an equation for this situation. I'll give you a hint. One way you could do it is slope-intercept form. Write an equation for this situation. Okay, so you might have written y equals 10x, where y is money earned and x is time worked in hours. Or you might have used the variables m and t. M equals 10t. Same equation, both are slope-intercept form. Either way, I can plug in how many hours I work for this X to determine how much money I earn, or I can plug in how many hours I work for this T to determine how much money I earn. Either of those work. So instead of y equals 10x or m equals 10t, I could write it as a function where the function of x equals 10x, and I could plug in different numbers for x and get different values for y. Try to make a function table out of this function, which this, all basically the same. Oh, you couldn't see that. This, all basically the same thing. But let's look at this. Let's make a function table. Make a table of values. Have an x column, a y column, plug in some numbers for x, get some numbers for y, and have your little function table. So depending on what you plugged in, I plugged in 0 for x and got 0, 1 for x and got 10, 2 for x and got 20, 3 for x and got 30, 4 for x and got 40. You might have plugged in different numbers and got different values, but you can tell that this is a function because every x value that I plug in gets a different y value. This is my domain. These are my range numbers. All right, if I took this function table and I asked you to graph it, and I'm not going to ask you to graph it, but I graphed it. So I'm taking these values, 0, 0, 1, 10, 2, 20, and so on, and I graphed it. It's important that I know how to label my graph. So my x-axis was time worked, and my y-axis was money or dollars earned. Your y values depend on your x values. How much money you earn depends on how much time you work. If I plug in 0, 0, 1, 10, 2, 20, 3, 30, 4, 40, 5, 50, I have created a graph. I can connect those, have a linear equation, and I basically just graphed y equals 10x. My y-intercept is 0. My slope is 10. Rise 10, run 1. Rise 10, run 1. But there's what a graph would look like. Again, it passes the vertical line test. So again, this one is a function. All right, so we've already discussed for what I plugged in for x, my domain was 0, 1, 2, 3, 4, and my range was these numbers. We've already discussed it is a function. Let me ask you this. What does a domain of 2 represent? What does that number 2 represent? Think about that. What does that 2 represent? It represents how many hours you cut grass. More specifically, it represents the fact that if you cut grass for 2 hours, you earn $20. 2 hours, $20. So let's use the same function that we created. Bill makes $10 an hour cutting grass. Here's our function. And let's find f of 12, which means how much does he make if he cuts grass for 12 hours? If f of x equals 10x, find f of 12. If you plug 12 in, you get 120. If Bill works 12 hours, he makes $120. So just wanted to have you see kind of a real life situation, very simple. Bill makes $10 an hour cutting grass. We were able to write it in function notation, slope-intercept form with different variables, write it as a function, a table, a graph, determine the domain and range. What does the domain individual number represent? And then work out some different function situations where he works 12 hours, how much does he make? 120. If he works 10 hours, how much will he make? Well, 10 times 10, he'll make $100. So that was a couple of real life function situations for you. Thank you.